All right. So this morning I wanted to first go over, I did get this exercise graded. And so if you have any questions about that exercise or what your grade was, we can talk about that. And also, if you didn't get the full, I think it was 10 points, and you want to resubmit because that was the very first kind of homework exercise like that, then I'll allow you to do that. And what I had the most problems with is, and mostly it was the online class that didn't do their flow charts, or where I explained several times in here that even though the problem said or, I wanted both, so I could see if you understood how to use Lucid Chart. And so that was most of the problems that I had. But some students, I think it was still in the online, there was a few that didn't even do the right problem. Number 6, they did the one that we did in class, which was a multiplication problem. So anybody have any questions about any comments, or you could find where I either commented yours, or if I didn't comment it, then it was okay. Any questions? I know there were, I don't remember if there was anybody in here that did this or not, but sometimes on the flow chart, let me go to Lucid Chart so it'll make more sense what I'm saying. Oh, and Ruth, did you have any questions? Because I know yours, I told you to resubmit it.
Yeah, I don't have any more questions. I submitted the wrong assignment.
That's what I thought. So no problem. I'll catch that. Okay, so let me I'll look here at Lucid Chart. So what I had some students kind of confused about is, and I can't remember, I think there was maybe one in here that did this, because the problem, chapter 1, exercise 6, actually asks you to do the sum and the difference. Then what I had some students do, and is they did this, and which was correct, and then they put their parallelograms for input, and then what they did is they drew 2 processing boxes because it was a sum and a difference, and they like drew a branch over here, and oops, I didn't mean to do that. So they had like 2 processing steps is okay, but just because there was a sum and a difference, you couldn't take the input in a flow chart and say go this way and this way. A flow chart, we haven't even talked about branches yet, which is a diamond shape. That's the only one on an if then else that you can branch. So your flow chart basically should have had these shapes. You could ask for both input in one box, or you could have done it in 2. It didn't really matter. So then there was 2 process steps, and then there should have been an output, and then there should have been an ellipse for a stop. So that's how your flow chart. And so if any of you did it where you had a process box over here and a process box over here, and you were saying pick between the 2, and then you had, they had this connecting here. This isn't right. They still had this one, like they were both coming out down here. But anyway, you can't just have one arrow and then have it go straight across connecting into 2 different boxes. Okay. So does anybody have any questions about that, how we did it? Okay, so you were supposed to have a pseudocode box here and a flow chart for problem number 6, and then you were supposed to have answered number 2 as just in a text box. It was just an answer to a question. And then I had, hopefully the online will look at this, none of you guys did this, but I'm going to reinforce this, that they just gave me the link to their Lucid chart instead of what we did, which we did the export PDF. And does yours on the Windows say export? Did we find out it does say export, not download as? Because last version of Lucidchart, I think it said something different. But anyway, if you do export PDF, so that's what you always need to do instead of giving me the link to Lucidchart. Okay, so the things that are due at midnight tonight, if you have any questions about the Unit 1, number 8, and the variables. This is the video where you go in. Let me click on this, make sure. I think some people have already done it. Let me see, and then I can show you what you submit. Yeah, okay, here's Quadri, right? That's okay. He did each one of the programs as a PNG of his pie chart that shows exactly what the guy did on the video, right? You typed it in and made it work. That's what I wanted you to do. So you didn't have to actually, on all of these assignments, the guy on the video, you don't have to give me your Python script. You just have to show me a screenshot where I can see that you have your source code and where it ran. Now, what I had said is if you knew how to save them all to a PDF, then you'd just submit one document. But this is fine too. There were 4 exercises that you were supposed to do. Right here, you had to do these, but you didn't actually turn in except for drawing a shape, variables and data types, working with strings, and working with numbers. Okay, so those are the screenshots that he turned in. So does anybody have a question about those? Because those are due at midnight tonight. All right, and the other one was that one that we did in class where we did part A of number 8, and you're supposed to submit. Oh, you were supposed to submit, let me find it, here it is, number 8B. So that's the one that you submit. These are 8A that we did in class, both the PDF, which will have pseudocode and flowchart, and then this is the Python script for number 8A. And so your assignment was to do the pseudocode and flowchart for 8B, and then also the Python script, okay? So those are the ones that are due tonight. So if you have any questions, we covered those in class last week, I believe on Monday. We didn't meet on Wednesday, it was a snow day, so we didn't go. Okay, so everybody should be done with, at midnight tonight, with Unit 1 out of MindTap, because that's where these problems came from. So if there's any there in the programming exercises that you want to do, we can do those before we go on to talk about Chapter 2 or Unit 2. Otherwise, I'm going to, let me go into MindTap. So if you want to, and it's next Monday is when I believe that I scheduled, let me make sure that's right. So all the things that, remember, I always have them do the next Monday, but we're going to start covering these. Okay, the Unit 2 test is due tonight too, because you were supposed to have read that while we were actually last week, because we're starting the lecture on it today. So you need 3 things. If you have not posted these 3 things, then you need to do that by midnight tonight. And remember, this Unit 2 test in Cengage, in MindTap, you can take as many times as you want to understand things, but we're going to talk about it today, so that should also help you. If you took the test and didn't get 100 and you want to get 100 on it, then maybe this will help. And then we may start on some of these, but these are not due till next week, okay? And this is the 3rd week. So this first test that we'll have hands-on test will be next week, and it'll be on the Wednesday. So we'll come in Monday and it'll only cover things that we've covered in chapters 1 and 2. but we may start lecturing on some more things on that Monday, depending on how much review we need. All right, so I'm going to go into MindTap. Oops, where's my login? And we're going to look at chapter 2. Keisha, you got in a little bit late. So after class, if you have any questions about it, because you had some problems with that Unit 1 exercise. So I'll try to stop a few minutes early and you need to let me know if you understand it, okay? All right, so let's see. Okay, so chapter 2 is and if you ever want to get a, you know, like a overview, the visualized little videos in here are the ones that give you an overview of this chapter. And order of operations, we're going to be talking about in the chapter, but this little video clip can help too. I just don't do them in class since you have them available to you. But this chapter, elements of high quality programs. So in this table of contents, here's where we're going to talk about variables and constants. And I believe in that video called Variables, why that's jumping around, he talked about constants, but if he did not, we're going to explain them in here. And so that's why I had you do the guy with the video working with variables, because it goes right along. He shows you how to implement variables in Python, whereas our book doesn't show specifically Python, but it talks about all the different types of variables, how to assign values to variables, how to declare named constants. And remember, this course is kind of like a generic course for all languages. So these things that are covered in chapter 2 will be true for any language that you code in, okay? But I think there is a couple of people that are programming. Who's in here that's psychology major? Like, so what, was this an elective or what made you want to take it? Oh, and it will transfer? Oh, that's awesome. Okay. You know, it's a basic one. And if you took it at OU, they only have languages. They don't give a course like this. And so it's pretty tough because they don't teach it. They give you a book. I've had students in it that took languages. So this was a good choice then if they transferred across. Okay, so in this chapter, we're going to become very familiar with variables. Then we're going to talk about performing arithmetic operations. And these are the same order of operations that you learned in elementary school about the community property, the associative property, all of the order of when you add or when you subtract. If there's a calculation that takes several different operations, you learn which one to do first. And then we've already talked about this a little bit because of Python. When we input a variable, it comes in as a string. And so to be able to work with it in a calculation, we have to change it to an integer or a float. And this talks about the integer data type. Then we talk a little bit here about modularization, even though we really don't do that a lot until I think it's another, I can't remember which chapter, but that's like taking chunks of code that we may want to use again in another program and saving it in a module. So that's what this part is talking about. A lot of times I skip over this part as far as us doing any coding in it until we get to where what's called the section called functions. So let's see, understanding the most common configuration. Yeah, we don't do hierarchy charts. We talk about them a little bit because it talks about them in the book, but I don't require that you use those. Those are really more for when we get to the module section. Okay, now we do talk about, we've already used in Python some comments. And this is where we ask for input. Okay, so, okay, how many have read chapter 2? Have I read it yet? Okay, so I'm gonna have to go over it some then. Okay, so we'll start here. And I'm not gonna cover all of it because I wanted us to be able to work some problems in class. If you remember, if you guys cover the information before class, then we can do more working on problems. So here, all data items that you use in your program have to be declared as variables or constants. And a constant is just a specific type of variable that doesn't change, just like the word, logically, the word constant means stay the same, stay constant, don't change. Whereas all the other variables can change throughout the program, and they're stored in memory. So when you write programs, you work with data in 2 different types, numeric and string, and in 3 different forms. Literals, which are unnamed constants, variables, and named constants. So these are, and we'll basically just be working with these 2. So you'll learn about those others if you take another language. So data types, most languages require that you put a data type at the beginning when you define the variable, but Python doesn't do that. But sometimes, like if, I'm gonna give another note here. Okay, so sometimes whenever I am defining variables at the top of a program, let me make this bigger. When I need to define variables, like when in that program for problem number 6, we did input, say we named it num1, comma num2. Well, that was our pseudocode, right? But so what are the variable names here that I'm using? Num1 and num2. Okay, you notice that I don't declare them. I don't say that they're number, or I don't say that they're string. But in our textbook, the way they have you do pseudocode, sometimes they'll have you at the top define all the variables that you're going to need. So for that problem number 6, I needed 2 output variables for the sum and the difference, and I needed the 2 input variables, right? And they were all numeric. So it may say num up here at the top to declare that it's a number, and then just list the variable names that I'm going to use in my program. And then maybe I would use, let's see, let's call the last one sum1, because you normally can't just use the word sum because that's a keyword in Python. And then let's just say difference, because that was the subtraction. So there, I've defined them all as numeric. And most languages, like somebody I think had coded in C#, may have been in my online class, there's C++, Java, JavaScript, all of those require that you tell whether the variable is a number or a string at the top. It's just that Python doesn't, so I don't even require it in our pseudocode. But if it makes more sense to you to be, when you read the problem, first thing, think about how many variables I'm going to need. And the difference in a variable and a constant is that if they give you a value and they say the tax percentage is going to be 8% all the time throughout the program, no matter how many hours or what you bought. Let's say this is a sales item. You're buying you're purchasing something. You're asking the user to give you the cost of a sales item, but it tells you up front that the taxes on that sales item will be 8%. Then that's called a constant. And if that was the case, okay, I'm gonna get rid of this. Then the constant, the difference with the constant is that, is that you would give it a name and like say maybe tax rate equals 0.08. Okay, so now throughout my program, instead of using 0.08, I would say tax rate. Okay, so I could name it so that I could at the top of my program, if tax rate goes up, I wouldn't have to change it every time that I was multiplying times the tax rate, because I would just say tax rate down here because it's still a variable, but I give it a value to start out with. Questions? I understand. Okay, so now these are the different types of numbers that we can define. We can define an integer, which is a whole number. A floating point is a fractional number. And we don't actually talk about real numbers, but there are some that, if you remember your mathematics, it's the same thing. And here it tells you a real number of floating point numbers. But what does it say? A fractional numeric variable that contains a decimal point. So if it's a float, it is a real number. So it depends on what language, programming language you're coding in. Is anybody in here going to take a programming language after this? Or just Python, just scripting? Anyone? No? Okay. I know I do have some in the online that are. So this will just have to do with Python. That's why it's called scripting, because it's a little less rules involved in script languages than there is in regular programming languages. So here's some constants that we're going to be using. And there's a video about declaring variables and constants in here. I'm not going to play it again, or not going to play it, but you guys should watch that if it's your first time to ever deal with variables and constants, and she'll cover what that is. In fact, I might go ahead. I think this one's really short. I want to do that.
Hi, this is Joyce Farrell. Let's talk about declaring variables and constants. A variable is a named memory location. If you couldn't provide reasonable names for the memory locations in your programs, you'd have to remember their memory addresses. It's much more convenient to remember a name. Like my age, perhaps where 27 is stored. Or my name, perhaps where Wendy is stored. These are different memory locations that have reasonable names. When you declare a variable, you must provide a data type. The two broadest data types are num and string. Many programming languages have several other more specific data types, but these two are the broadest types that hold numeric data and string data. When you declare a variable, you must also provide an identifier. An identifier is the name for the variable, which has to be one word that starts with a letter and not have any spaces embedded in it. When you declare a variable, you also have the option of providing a starting value. If you provide a starting value, it's called an initialization. The starting value is an initial value. For example, you could declare a numeric variable called my age by giving it the data type num, calling it my age.
Now you'll notice she is putting num out here, and that's how it'll be defined in the book. And if you do your pseudocode that way, that's no problem. That helps you remember that this variable name has to be numeric. So in Python, when you ask for input from the user and you say, put in the input, then you know that you have to either in that same statement convert it to an integer like we did in our Python statements. And I think he does in that those screenshots that that video that I have you work with. But he you can either do it that way, or you can have a separate statement that converts it. So this is optional in your pseudocode, but it does remind you that in Python, you do have to make sure once you ask for input that it's numeric.
And providing a starting value of 27. You could declare another variable, numeric your age. If you don't provide a starting value, that's okay, but garbage is stored there. Garbage is an unknown value that resides in a variable that has not yet been assigned a value.
Okay, so that's what she's saying here. And we don't usually do this in Python either, but all other languages, you either, when you define a numeric variable, if you don't put something in it, and she's saying assign, remember the equal sign in programming is called an assignment because it assigns whatever's over here to the variable. So it's assigning 27 to my age to start out with. But it says because this is going to be an input variable, you could assign it 0 so that you're sure there's not anything already sitting out in memory. So all you're doing is giving a name to a place out in memory in the computer. And so if you don't give it a value at the beginning, you don't know what might be there. So a lot of times you're safer, and most languages do require that you initialize it if it's numeric to a value or to 0 so that you know nothing is in there. But Python doesn't require you to do that. So it kind of helps you develop some bad habits if you're going to program in any other language. Any questions about that? Does that make sense?
After you've declared variables, you can change the values stored there by assigning a new value to them. For example, my age equals 37, assigns 37 to my age. And your age equals 19, puts a 19 where the garbage to be in your age. You can do arithmetic. Your age equals my age minus 3. That changes your age to 3 less than 37 or 34. You can declare a numeric variable total without a starting value, so garbage is stored there. And then you can assign arithmetic to it. Total is my age plus your age. The addition is performed, and the total is stored at the location named total. You might declare another numeric variable named total 2 with no initial value. Garbage is stored there. And you declare a variable Tom's age with no initial value. Garbage is stored there. And when you do the arithmetic, total 2 equals my age plus Tom's age is illegal because Tom's age has garbage. It cannot be added to my age. You might declare a string variable, my name, and initialize it to Wendy. You might declare another string variable, your name, and not assign any initial value and have garbage stored there. You could assign a value to my name later by storing Jake there. You could assign a value to your name later by storing Alice there. You could try to assign my age to my name, but you can't. It's illegal. The data types have to be the same. Only numeric values can be assigned to numeric variables. Only string values can be assigned to string variables. Declaring named constants means providing a name for a memory location that is not intended to change. By convention, most programmers use all uppercase letters for their named constants, and you can assign initial value there. In many programming languages, you need an additional word like constant or final in front of the declaration. Once a constant is declared,
This is called a declaration. That's what she's talking about. Whenever you declare a constant or variables at the top. And when we do that in Python, we usually put a comment at the top that says declarations. And you'll see that in her pseudocode too in the book, where it'll have / declarations. That's a comment that says, here's our constants and our variables that we're going to be using.
Stored in memory. You might attempt to change its value by making a statement such as tax rate equals 0.04. That's illegal. A constant is intended never to change. That's an overview of variables and constants.
Okay, so I just wanted to show that one so that you would know. Those are very helpful if this is your first time to ever be in programming. I know they're very simple, straightforward, and may seem redundant, but some students, this is very new. And so I just wanted you to be aware of all the resources that are here to really help you. I know I had one student say they don't do well watching the lectures or whatever. Well, that's fine, but a lot of times the book, I cover things a little differently so that people have different ways of understanding things. And the book doesn't use any examples of languages to be applied. So but that does help, all her little videos. So here is a problem. Variables are name memory locations whose contents can vary or differ over time. For example, in the number doubling program in figure 2-1, my number and my answer are variables. At any moment in time, a variable holds just one value. Sometimes my number holds 2 and my answer holds 4. At other times, my number holds 6 and my answer holds 12. The ability of variables to change in value is what makes computers and programming worthwhile. Because if you, in the beginning, when you write a program, if you initialize every variable to a specific number, then you can't change it. If you make it a variable name and ask for input, then every time you run it, you can run it with different values. So one set of payroll instructions at your company produces each employee paycheck, and one set of instructions at your electric company produces each household's bill. So they just have one program and it runs with however many thousands of customers that they have. But because it works one time, it's going to work with every customer with different values. So here is what we've been working on in chapter 1. We already did a problem with the sum of the difference, but here's one, number doubling, and it's the pseudocode and the flowchart. And what you notice is in pseudocode, each one of these steps has a specific shape that it goes into. So our start is in the ellipse. So I'm saying that to say, whichever is easier for you to understand the flow of the logic, you can do it first and do the other one second. Some people are fine with pseudocode. Some people understand that the steps by the shapes, and that's why these shapes are so important, that you get the correct ones. Input and output are parallelograms. Processing step is a rectangle. So we're going to learn a new one in this chapter. Or wait, I'm not sure if it does. I think it's chapter 3 that we go into the new one. So in most languages, we have a declaration. That's a statement that names a variable and its data type. So that's what I would, and optionally an initial value. So if you want it to start out with a certain value, you can do that. So here's a numeric variable, is one that can hold digits and have mathematical operations performed on it. So in the statement, my answer equals my number times 2, both my answer and my number are numeric variables. That is, their intended contents are numeric values such as 6 and 3, 14.8 and 7.4, or negative 18 and negative 9. So as long as it's a whole number, it's an integer, even if it's a negative number. But these would be floating point numbers because they have decimal points. A string variable, what do you notice different about when you set a string variable equal to a variable? Oops, I don't know why I didn't. What does this, how does this look different than when they set my answer equal, or my number equal to 2? What's different in a string that you have to do? Quotes, you meant. Yeah, I know what you meant. Quotes has to go around every string. And when you print it, you're right, there has to go parentheses around it also. But when you're establishing a string variable name, you have to put whatever value you want dumped in there or assigned to there in quotes. See, a zip code is also a string because it's not a number that you want to do a calculation on, right? So type safety, it's telling you how important it is to, if you declare tax rate as a numeric variable, an inventory item as a string, then the following statements are valid. 2.5 in tax rate, and then monitor in an inventory item. So this one is invalid because here, this is supposed to be numeric, and if they put this in as a string, you won't be able to use it in a calculation, okay? And this is supposed to be a string, and so you can't put it in there without the quotes on it. So I'm not going to watch that one, but you all, if you have any questions, go ahead and watch those. So identifiers, it is a program component's name. It is chosen by the programmer. The number doubling, so the variable identifiers are the names that you use. And remember, you can pick any name that you want, but camel casing is what this is called when you have two words, but you cannot use a space in a variable name. Some people use an underscore to represent the space instead of the capital. It's whichever formatting makes sense to you. So, let me go down, see if I see another one. Some languages allow $ or other special characters in variable names. For example, hourly like this. Others allow for an alphabet. So you have to know what the keywords, they're called, are for each language. So in Python, if you notice in PyCharm, if you were to type in sum as a variable name, it would change color because it would tell you that's a keyword. So you can't use it as a variable name. And every language has certain words that are part of that language, and so you can't use them as a variable name. Now I could put a 1 on the end of sum and it would no longer be a keyword. Okay, so there it talks about the camel casing. And so it says adopting a naming convention for variables and using it consistently will help make your programs easier to read and understand. So whichever one you choose is fine. It's just that you need to either decide, okay, I like camel casing, or I like to put an underscore instead. So you choose, and it's not going to be wrong if you do a combination of those, but it's better to become consistent with your variable names, how you do your variable names. And when we do constants, and I think they're going to talk about that in a minute, normally everybody makes constants all cap because then you know right off that these are variables that don't change. So that's different than the ones like this. So you don't want to ever make regular variables all caps. It wouldn't give you an error. It's just that it's hard to read and understand your program if you start doing things like that. And most of the time, you remember in algebra, they would use just one letter variable names. Well, it's not really a good idea to do that because when you go back and look at your program, you don't know what that one letter represents. So it's better to use meaningful variable names. Variable names must start with a letter. So up here it said they must be one word, which means no spaces. They must begin with a letter. And sometimes these editors, like PyCharm is considered an editor, and but like Java and C++, Visual Basic Studio is considered an IDE, which is an integrated development environment, which means that you can edit it and compile it in that same editor, but we won't be using one like that. Although in PyCharm, you know, it runs even though it's not compiling because script doesn't require that. It just interprets it. Okay, so here's another one. Figure 2-2 follows the preceding rules for variables. Both variable names, my number and my answer, are single words without embedded spaces, and they have appropriate meanings. Some programmers name variables after friends or create puns with them, but computer professionals consider such behavior unprofessional and amateurish. So, like if you were in elementary school learning, and which they do learn programming. Did any of you all learn to write a program in elementary school? Nowadays they do. They're so far ahead. Okay, so flowchart and pseudocode of number doubling with variable declarations. So you'll notice from the last pseudocode, they've added the step that I told you would be in most of the rest of the pseudocode and flowcharting. Is it's a rectangle shape and it's the declarations. And so every variable that's going to be used in the program is declared at the top. And that's a good idea to do that. Even though Python doesn't require it, you can do it as a comment so that when you look at your program, you can see that these are the variables that are going to be used. So here's assigning values. This statement is called an assignment statement because, like I was telling you, the equal sign is an assignment operator. It actually will evaluate what's here and dump it in what's on the left side. So the equal sign, it's called the assignment operator. It's a binary operator. What does binary mean? What is bi? 2. So that means this operator takes two sides. It takes two parts. It has two parts to it. It has a part on the right that is dumped into the part on the left. An operand is simply a value used by an operator. Here's where I was telling you about right associativity or right to left associativity. So what that means is the descriptions of operators that evaluate the expression to the right first. And so what I was telling you happens with an equal sign, everything on the right is evaluated first and dumped into what's on the left. So here are some valid assignment statements it shows you. And here are some invalid ones because the equal sign is on the wrong side, right? Because it's going to evaluate what's over here and it's going to dump it over here, but it's not going to do the calculation. So initializing a variable is starting it with a value. So like down here, your salary is initialized with this value in it, and your name is initialized with Juanita. So the others are called garbage because they don't have anything in them yet. So where we declare variables is always at the top of our program. Then besides variables, there's a named constant. It's similar to a variable, except it can be assigned a value only once. We don't really talk about magic numbers. That's a little bit more advanced and very confusing. So here's a constant that's defined 6%. And you'll notice in pseudocode, they put num out here. Now, Python won't even let you do that. So that's just a pseudocode thing to help you to understand that this is a numeric value. The way in which named constants are declared differs among programming languages. And so with Python, you don't have to put constant out before it. Whereas in some languages, you do have to let the language know that it's a constant. Okay, so these are some questions that you can ask yourself to see if you understand. Okay, so we're going to do this part, and then we're going to go to the review exercises, and we may do a Python in PyCharm so y'all don't fall asleep here. Okay, so we're just going to scan over this real quick. The performing arithmetic operations, the plus sign, minus sign, asterisk, and the slash is division. And so then we have the assignment operator. So when you add two things, it adds on the right, dumps it in the left. Rules of precedence and order of operation. Now, these are the same as they were in mathematics, but you may not remember that expressions within parentheses are always evaluated first. So if you have a real long calculation with pluses and minuses and division and multiplication, you may want to put parentheses around the ones that you for sure want first. But if there's no parentheses, then multiplication and division are evaluated next from left to right. So on this side, like of the equal sign, if you have multiplication and plus, and you don't have parentheses, it would first multiply E times F, and then it would take the result of E times F and add G. And then that's the value that would be assigned to D. So if you're not sure about the rules, they're right here for you. Addition and subtraction are evaluated next from left to right. So those are the rules. So here, first answer equals 2 plus 3 times 4. Well, in order to get it to evaluate 2 plus 3 first, you would have to put parentheses. Otherwise, it's going to do 3 times 4 first, right? Multiplication and division first. And the answer will be different. So here, if you're going to average, forgetting about the rules of arithmetic precedence or forgetting to add parentheses when you need them can cause logical errors that are difficult to find in the program. For example, the following statement might appear to average 2 test scores. Average equals score 1 plus score 2 divided by 2. However, it does not, because division has a higher precedence than addition. So it would do score 2 divided by 2, then it would add score 1 to that, which is not what you want in an average. What do we need to do if we were averaging? What's that? Parentheses around score 1 and score 2, right? Because you want to add those two together, then divide by 2. So this is correct way to do it. And there's some more examples. All the arithmetic operators have left to right associativity. Describes operators that evaluate the expression to the left first. So if there are no parentheses, then, and there's multiplication and a division, you would start with whichever one was to the left, farthest to the left. So like this one, what is going to be evaluated first? CD, right? So it's going to be, okay, I want to take this and, oops, see if it'll let me, no. Okay, so if I take this one and I say, oops, okay, and I say answer equals A plus B plus C times, I'm find the times D divided by E minus F. Okay, so according to the rules of precedence, what needs to be done first? Somebody told me already, right? C times D. So I'm going to do C times D first because its multiplication and division have higher precedence from the left. So then once I do C times D, I'm going to do divided by E. And then it would follow giving a new result. So the statement becomes A plus B plus temporary result just calculated minus F. So if I'm gonna go up here and give them values so it'll make more sense. Go up here and say A equals 2 and B equals 1. I should have just left them all. C equals 3 and D equals 4 and E and F, right? E equals, I can do the same one, 5 and F. So let's say F equals 6. So now if I was working this problem out without any parentheses, I would say C times D. So what's C? 3 times 4 is 12, right? So my second step would say answer equals A plus B plus 12. Is that what I said? 12 divided by E minus F. So what would I do next? What's my next step? Okay, so what operation do I perform next? Quadruplication, anybody? Divide by E, because what does it tell me in my rules? Multiplication and division have higher precedence from left to right. So I don't have any other multiplication to do, and I started with multiplication because it was left of the division. So now it's 12 divided by E, and what's E? Oh, let me make this a better, easier one, 4. So 12 divided by 4 would be 3. So I'm going to go down here. Oops, my next step. Oops. So now I know that this is replaced by 4, right? So now I'm getting it down. Now what's the next operation that I need to do? F, are you sure? It's addition and subtraction from left to right. So which one is the farthest left? A plus B, right? If you guys, one of y'all don't understand, please ask. Some of y'all aren't looking. Be sure and ask if you're not getting it, because I only hear one person answering or two. Okay, so A plus B is going to be 2 plus 1, which is 3. So now I'm going to go down here and I'm going to say, oops, that one I'm going to do. A plus B, I'm going to replace with 3. So now I've got 3 plus 4 minus F. So which one goes next?
3 plus 4.
Okay, very good. 3 plus 4 is 7. So now I've got 7 minus F. F is 6. So it'd be 7 minus 6. And so my answer would be 1. Okay, so that is how, if there's no parentheses. But if you set it up with parentheses, then you don't have to think about all those orders. So if you know that's the way you want it to be done, then this is a way to set it up where it will for sure do that way. So in here in your book are the order of precedence if you don't remember. And there's another little video. Okay, I think the integer data type, we should be okay with that. Let me see. Okay, we're not going to go into modularization today. Okay, so we're going to go down to the review exercises first. Make sure we got those down. So, review questions. What does a declaration provide for a variable? A name, B, a data type, C, both of the above, or D, none of the above? C, very good. It gives it a name and a data type. And remember, in Python, you don't have to give it the data type, but it's good to do that in a declaration. So a variable's data type describes all of the following except what value, A, what values the variable can hold, B, the scope of the variable, C, how the variable is stored in memory, D, what operations can be performed with the variable. So which one is not true? B, okay. So scope, we haven't even talked about yet. That's in a function or in modularization. Okay, so the value stored in an uninitialized variable is A, null, B, garbage, C, compost, D, its identifier. B, very good. The value is the value 3 is a numeric, B, string. Yeah, somebody already said A, that's correct. It's a numeric variable. Actually, no, it's not a variable. It is C, a numeric constant, because it's saying if the value's 3, it can't change, right? So number 5, the assignment operator is A, is a binary operator, B, has left to right associativity, C is most often represented by a colon, D, 2 of the above. A is a binary operator, correct, because it does not have left to right associativity. The assignment operator has to go from right to left, correct? So multiplication has a lower precedence than, which one? Division, subtraction, assignment, or none of the above?
B.
Which one?
B, subtraction.
It has lower than subtraction? No, it has higher. So the only one it would be, that's okay, is it actually, it's a none of the above, because it's the highest. Multiplication and division are the highest. Which of the following is not a term used as a, we're not going to do the rest of them because these have to do with modularization we haven't talked about yet. But when you read that part, these questions are in your Unit 2 test that you take, okay? So you will have that terminology because that's due, remember, by midnight tonight. All right, so we're going to look at this first programming exercise. Is actually not a programming, it's just to ask you about variable names. So explain why each of the following names does or does not seem like a good variable name to represent a state sales tax rate. Okay, is that going to be a variable or a constant? The sales tax rate. Well, if you're going to give the sales tax rate before you start the problem, then it's a constant. And it actually, none of these are all, I guess they're not making it a constant. Oh, okay, you're right, just right. Because that it's not telling us that it's a constant, it's saying a good variable name. So this could be a good name. This one's a little short. You wouldn't really know what it stood for. Some people might. This is not, why is this not a good variable name? C. What? It's a letter and you don't really know what it is for. This one is a little long. I'd hate to type it in a bunch of times, right? So it's a little bit long. What's wrong with E? Spaces. Okay, this one would work. What's wrong with G? It starts with a number. Money charge, that could be okay, but it really doesn't tell us what. No, that's really not a good one because it's not indicative of what that value is supposed to be, represent. Okay, this is another, if product cost and product price are numeric variables and product name is a string variable, which of the following statements are valid assignments? If it is not valid, explain why not. So product cost equals 100. Is that valid? Yeah, because it's a numeric. Then you could say, since this is numeric and price, product price, you could say product cost equals product price. That's probably, I mean, it's valid. What about this one? C, is it valid? Why not? Like, doesn't, it's a variable. I mean, I'm sorry, this is string and this is numeric, right? Right? Okay, D, is D valid? No. Somebody else tell me why. Alan, why is it not valid? It's in quotes, right? Okay, because it's in quotes, which says this is a string and I'm trying to place it in a numeric variable. What's wrong with E? It's on the left. Very good. This value should be on the right. F. Probably not work. It will not. It's not probably. A $sign and a comma are not, you can actually use a decimal point, but you can't use a comma and a $sign unless on output you define that as a string, that portion as a string. Product. Okay, is this one valid? G. Should be, right? Yes. Product name equals mouse pad. Is that one right? That's valid. Even though it has a space in it, it's a string, so you can put a string into there with a space in it. Okay, I, is I correct? Valid. No. J. No. Is K? No. L? Yes. M? What's wrong with M? Backwards, right. If any of them that were going too fast, somebody has a question, please ask. This one, no. What does it need? Quotes. This one, product name, backwards. This one, that doesn't make sense why you would want to set it to itself, but it is valid. Okay, I'm gonna let y'all calculate those out on your own. So number 4 tells us to draw a typical hierarchy chart for a program that produces a monthly bill for a cell phone number. Try to think of at least 10 separate modules that might be included. Okay, now this is something that we're not going to do a lot of, these hierarchy charts, because they're having you already think about modules. But like, I'm going to go back and let's try this in Python, one of these ones that we did in the chapter. Okay, so go ahead and open up. We got 10 minutes. We can do one. Open up PyCharm or idle, as everybody has PyCharm, I think, on your computer. So now remember, I can write, I don't want that. Why is it doing that? Okay. PyCharm would like to, that way. Okay, I'm going to right click on that folder at the top, click on new, should pop up with Python file. And then I'm just going to name this chapter 2 example EX. And it's a Python file, so I don't have to put .py, it should do it for me. So up here, now I should have chapter 2 ex.py. All right, so first of all, I'm going to do declarations for, let me bring this problem up. Let me go back to where we did that. Okay, the first one, I think maybe this was a problem. Let me see if this one had a problem in it. Okay, let's do where we assign. I want to do modular. Got one of them. Okay, we're declaring. Okay, we're going to have, let me see what that problem was without doing the hierarchy chart. We'll see what the problem was. We're not ready for the hierarchy chart yet. Okay, so here it says we want to produce a monthly bill for a cell phone customer. One module might calculate the charge for daytime phone minutes. Okay, so yeah, these are just the modules. These aren't telling you exactly. All right, so if we're making, let me go back to PyCharm. Okay, let's make declarations. So we're going to do / for, oops, for our comment. And so we're going to say declarations. And our declarations are going to be, we have to have the cost of minutes of the phone bill. And so we'll just say, let's name this variable minutes, and it equals 0. So we're going to initialize it. We're making these declarations. We're going to have minutes and the cost per minute. So let's just say cost per minute. Actually, this is going to be a constant. So what do I need to do different on a constant? What did it say on a constant? All caps, good. So I want to say cost per minute is equal to, so let's say the cost per minute is, what, 30 cents? That's pretty cheap, isn't it? 30 cents. Okay, and we want to ask the, so we're going to ask the user how many minutes on this cell phone bill they talked. We're going to calculate using the cost per minute. So we're going to give them their bill total. So we'll just call this bill is equal to 0, because it's going to start out with 0. So that means there's no garbage in there when I do that. So those are the declarations that I'm going to use in my Python. But I don't know why this isn't a different color. Should be if I did the comment right. Am I doing the comment? I always forget that. Thank you, Joseph. Okay, pound. That's because JavaScript does the slashes. Okay. And I can tell that that's a comment because it graded out. Okay, so now I want to go down and I want to ask the user for minutes. So I'm going to say minutes equals, and it needs to be a integer or a float, either one. If they had half minutes, I guess. And then input, please enter number minutes talked.